Good morning, everyone. And we'll let some folks get in while we set up for today's session on the future of self-sovereign identity. I'm Michael Marchant, and we're excited to have you on board here. As folks are joining the webinar, don't have any holiday music to play in the background, but I have added the festive Santa hat, since we're going to be giving you the gift of information today on blockchain. And with that, that gift can be given to not only yourself and your brain, but your organization. And we have two exciting speakers with us today that will be sharing their information, their knowledge, their experience, and really helping us all understand why blockchain is an important and integral part of identity for organizations, for the country, and even for the world and some of the efforts that they're participating in. And we're really excited to have you on board today. So without further ado, we'll go ahead and introduce our two speakers. Go back to that one slide, just leave them up. Well, you can, yeah. So again, I'm Michael Marchant. I'm the Director for Health Information Exchange at UC Davis in Sacramento. I'm a member of the HIMSS Blockchain Task Force for the last few years. And we're really excited to have Jim St. Clair. Unfortunately, his title slide there didn't add the saint, but he is a saint for being here and matching me as in our pre-show meeting with the festive hat there. Jim is the Executive Director of the Linux Foundation. And really, he builds, secures, and sustains open source software to help public health authorities and other healthcare organizations with an open source digital health ecosystem. Jim is an active technology strategist with 25 years. His age, you can't see that in his face, is just young and on that boat in his background there. Experience in healthcare, government, and other industries, working with blockchain, artificial intelligence, robotic process automation, cloud technologies. He's also active in several industry associations, including HIMSS, the Blockchain Task Force. He recently joined the Care Quality Advisory Council and is contributing to several ISO, HL7, and IEEE working groups to develop new standards for decentralization of identity, patient data, distributed ledger systems. And Jim was inducted into the Federal Health IT 100 Hall of Fame in 2021. Hopefully, Jim, you got like a yellow jacket like the NFL Hall of Fame. So Jim's very energetic speaker. We're glad to have him here. And last but not least is Jim is a veteran and a former naval officer. So having the boat in the background is very appropriate for Jim, having served in both active and reserve capacity. So Jim, thanks for your service, and we're glad to have you here today.
It's a pleasure to be with you as always, Michael. Thank you.
Thank you. And then with Jim is Kapil Bereja. Sorry, Kapil, I'm going to mess that up. He's a leader with over 17 years of experience in various disciplines of information security, specializing in identity, access management, government, cyber risk, network, and cloud-based security solutions. Kapil's serving as a member of the Technical Governance Board that is responsible for governing the technical design, architecture, implementation, and operation of the sovereign network as a global public utility for self-sovereign identity. He's also part of the Trust over IP stack, confluence of multiple efforts in the digital identity, verifiable credential, blockchain technology, and secure communication. He's also serving as a contributor and member of two industry foundations, the Decentralized Identity Foundation and the Open Identity Exchange, the international not-for-profit clearinghouse for Internet Trust Frameworks. He's also served as an advisory member of the Open ID Foundation and Cloud Native Computing Foundation. We're great to have you here. We appreciate your time and sharing your knowledge this morning. So again, get buckled up for some exciting news and information and energy from Jim and Kapil this morning. And what I'll do is we'll go ahead and turn that over to Jim. Jim, you have the floor, and why don't you take us off and show us what you know.
Sounds great, my friend. I appreciate it. It's great to be with you and with Kapil. And for purposes of full declaration, Kapil and I are both involved in several, obviously, the Linux Foundation activities, Decentralized Identity Foundation, Trust over IP Foundation, and then previously worked with Sovereign. So very excited to be able to talk about self-sovereign identity today. First thing I wanted to do was just describe definition-wise what self-sovereign identity was all about. And it's based on the principles of enlightenment. And yes, that's the principles of enlightenment going back to the 14th century and the UN Universal Declaration of Human Rights. It begins with a basic premise that you should control your own identity in regards to your relationships with other people, organizations, and things, but that you have sovereign ownership of those identity elements as part of your rights as an individual. Next slide, please. The challenge we have with digital identity as it has grown today and continues to foster is that they're largely administered by centralized authorities. And while they could be governments, corporations, and software platforms, unfortunately, the trend for the most part is towards identity service providers that are corporate-based rather than government-based. Each of these organizations has a vested interest in managing both online and offline identities. And for corporations, unfortunately, they also have commercial interests for managing those identities and locking out other authorities from changing or profiting from the way that those identities are used, often at the expense of the individual. Next slide, please. When Kim Cameron invented and Philip Windley invented the 10 principles of self-sovereign identity, they were organized around these principles of human rights and how the individual controls their existence. You can take a quick look through the list there. Some of the most applicable from the standpoint of healthcare, which Michael and I are both involved in heavily, is portability, interoperability, and consent. And I would offer separate meaningful conversations around the concept of consent to share your information. And of course, everyone is familiar with granting consent for sharing data and clicking yes for cookies. We offer that consent and elements of identity are very closely related and interdependent with each other as part of sharing your information and sharing your identity, because a lot of times your consent to your data relates to who you identify yourself as an individual to be, and those elements of identity and what you feel is sensitive or should be retained by you as elements of identity. Next slide, please. When you look at the concepts of self-sovereignty in the General Data Protection Regulation, the GDPR in Europe, you'll see the relationships there between the 4 major tenets of GDPR and the concepts of self-sovereign identity that I showed in the list of 10 items there on the slide. Data protection, the concept of the identity itself, your right to privacy, and of course directly related to privacy, of course, is consent and consent to share information, which is built upon a fundamental understanding or expectation of data protection tied in with your identity to that data and your consent to share it in a private fashion. Next slide, please. There have been 3 eras that you can define for internet identity. The first was centralized. We touched upon that. That's still very popular. It's just the concept that there is a centralized organization that you interface with to share your identity verification and authentication with. We've been moving more and more into the world of federated meaning that there's relationships between organizations, but you oftentimes have a centralized or slightly decentralized model for an identity service provider that you then use for sharing that identity across multiple domains, but there's still an identity service provider helping to provision it. And then lastly, decentralized. And as you can see from the graphic, that involves things like the World Wide Web Consortium standards for verifiable credentials, the Decentralized Identity Foundation, Trust Over IP Foundation. And that's ways to use these verifiable credentials in conjunction with decentralized identifiers to allow you to manage your identity and the attributes of your identity on your own in a person-centric, patient-centric method, and through trust frameworks in a completely decentralized way that doesn't rely on centralized or federated identity service providers to attest to your identity information. Next slide, please. As an example of this, the recently established and quickly being adopted Penn Canadian Trust Framework, similar in principle, and Canada has similar principles in privacy to the General Data Protection Regulation, GDPR, and they're now beginning to recognize and implement a trust framework built on this concept of decentralized identity, where there is acceptance and mutual recognition of digital identity of persons and organizations, and then a relationship between those persons and organizations for how those digital identities are shared. It's intended to be technology agnostic, but built upon an open source framework and leveraging standards and specifications from those organizations that I mentioned before. And it's intended to help facilitate the transition from legacy identity technologies, which is a mix of centralized and federated, to a model of self-sovereign identity within the public sector within Canada, starting first and foremost with Ontario, and then moving into other provinces from there. Next slide, please. So let's talk a little bit about verifiable credentials and what they are. And as I mentioned, they are built on a World Wide Web Consortium W3C standard. They're intended to be all digital and truly under the owner's control, have high scalability because of their cryptographic makeup, because of their cryptographic composition. They're harder to fake and harder to impersonate the true owner. It eliminates the need for what we call treasure troves of data. I'm sure many of the people on the webinar are used to these cases of seemingly endless requirements to affirm or attest to your identity by supplying the same personal information over and over again as you move through checkpoints or verifications and processes like at the airport or for paying a bill, etc. And eliminating that through a simple cryptographic proof that relies on a trust framework to be accepted. It also enables things around minimal disclosure of information, something we call zero knowledge proofs, which I'll touch on a bit, and I think Kapil touches upon as well. And the data by itself becomes useless to thieves because it's associated, again, with that decentralized identifier and hopefully has encrypted data in the back end. So the only individual who can manage that data is you. Next slide, please. That trust registry or trust framework model I refer to is built around the principle of the verifiable credential trust triangle. You have an issuer of a credential, you have a holder of the credential, which is the individual with their digital wallet, and then you have a verifier. And there's some trust framework that allows the verifier to trust the issuer as the credential being valid. So the holder presents a credential, is attesting to say, I am who I say I am because of this cryptographic credential. You trust the issuer of this credential, you have verification, I'm presenting it, and you can trust that I am who I say I am. Why that's important is because the basis of what that trust is may be very simple. Again, on the principle of minimal disclosure, you may only be providing 2 or 3 elements of information that you choose to disclose as part of that verification process, and not, constantly reproduce your driver's license, social security number, social insurance number, etc. And the basis for that, and of course why it's important for this conversation and for a patient tour area of work, is that the verifiable data registry, not personal information, but the data registry associated with that cryptographic verifier is built upon a blockchain. Next slide, please. As you can see there, the issuer writes a decentralized identifier using a public key and other cryptographic metadata to an underlying blockchain layer, and does not leverage personal identifiable information, and then generates the verifiable credential and issues it to the holder. Next slide, please, or next clip. Yep, go to signs. That's digitally signed by the issuer. The holder presents it as proof of their identity attestation to the verifier, and the verifier reads it. And no integration is needed. There doesn't need to be a direct system of trust between these organizations in terms of a physical connection or sharing PKI certificates. All of that is done through a trust framework, through a governance framework that's agreed upon between issuers and verifiers, and leveraging the exchange of public keys. The concepts of zero knowledge proofs are that the decentralized identifiers are private to the individual, but can be exchanged in connection with the public keys, so that the holder only has to disclose the cryptographically verifiable credential and doesn't have to necessarily disclose additional information to prove who they are beyond the information that they're providing in that credential. Next slide, please. So in a fully implemented trust framework with self-sovereign identity, You combine the use of decentralized identifiers and verifiable credentials, and that gives you the opportunity to implement privacy by design. And the bullets below list the principles of the privacy by design. If you get a chance, you can Google Dr. Ann Cavoukian, formerly a privacy commissioner in Canada, who has pioneered the concepts of privacy by design, which essentially, as the bullets note, that privacy should be a default setting. It should be designed, it should be embedded into the design of any system. Concepts of privacy and protecting data should be proactive, not reactive. It shouldn't be something that's bolted on. You shouldn't have to remediate the design of a data or information flow in order to build privacy into it, but be preventing disclosure of information upfront, which of course supports that concept of a zero knowledge proof. It should have full functionality throughout the system, so it shouldn't be a case where you'll lose some sort of functionality. Either we offer this service to a customer for their convenience without privacy, or else we take it away in order to protect privacy. That's inherently in conflict with the concepts of privacy by design. There should be a seamless user experience protecting their privacy and their information, from the start. End-to-end security, which we demonstrated as part of the concepts of the verifiable credential and the use of public key and private keys. Everything about the system should be visible and transparent, which is why Kapil and myself are actively involved in aspects of the Linux Foundation, where everything is built in an open source, consensus-driven, transparent manner for the architecture, and ultimately respect for user privacy. And that user privacy respect may be a regulatory framework, it may be human rights principles, or just agreed upon ethical framework, but it should always be user-centric in that regard. Next slide, please. As an example of this sort of SSI technology that is in use today, you have the International Air Transport Agency, the IATA Travel Pass. It is built to be an at-home digital passport verification or pre-departure COVID-19 testing. You get the shared travel documents with airlines, airports, and border authorities. But most importantly is that you retain the information that a border authority or a health authority either provides you or that you have to verify. But the airline, for example, doesn't become a holder of your personal data. That's still under your control and shared as you choose to share it in those circumstances where it needs to be shared as part of a cross-border verification or a health verification check. But privacy is maintained by you at all times. In the future, there'll be a certification mechanism that they refer to where, again, you provide that cryptographically verifiable certificate without disclosing an array of health information to support it. Next question, or next slide, please. And we'll skip through this. It's essentially demonstrating the same the same verifiable credential trust triangle using the IATA Travel Pass example. It's writing to the sovereign blockchain, of which Kapil and I have both been involved in sovereign, maintaining an SSI distributed credential network. The testing lab, for instance, or a vaccine distributor, such as a hospital or pharmacy, may be the issuer of the credential. That issued credential becomes a travel pass that's held by the traveler, who is the holder, and they provide that as proof to the airline in a zero knowledge proof type manner, or for the sake of border checks for verification purposes. Next slide, please.
I think that's it, Jim.
It is. Thank you very much, and I am open for any questions and happy to turn it over to my colleague, Kapil.
Yeah, nice. I really appreciate that. And Chris had put this in the chat, but I also not only did Jim share a lot of information, but we also encourage the audience to participate. There's a Q&A function that you'll see at the bottom of your screen there, and just drop some questions in. We have a Q&A period at the end of the session, so if you have some questions, we can work through answering them there. And you drop them in the chat or in the Q&A session, we can go through them at that point. So I'll turn it over to Kapil to talk about his information and share his wealth of knowledge. Kapil?
Thank you. Thanks, Michael, and thanks, Jim. I just want to talk about a little bit more on self-sovereign identity and focusing mostly on what work has been done and what the future looks like to be. So this is like my background, and Michael already provided a good introduction about where I am part of, and different organizations and standard committees who are focusing on implementing and doing a piloting for some of the blockchain solutions on the self-sovereign side. Next slide, please. So this is kind of an SSI meetup we have from the self-sovereign identity perspective, and I would like everyone to join. And it's kind of in a global SSI communities that is open for everyone, and its content is being shared by the contributor who basically part of that organization, and they have a full leverage to contribute and throw some ideas what they have in their mind to create a shared ecosystem. So please, next slide. This is my year of experience. I think we already been discussed, but yes, this is 17 years for me in identity, and specifically 13 plus years of internet identity workshop. I've been part of and did at least 26 instances from the blockchain and the decentralized perspective. My experience from 15 years in the identity standards, focusing on W3C, OSS, IDF, OpenID Foundation. So working very closely with the, some of the technical leads and the governance board over there to strategizing some of the future roadmap on the self-sovereign side. Next slide, please. So as Jim mentioned, what self-sovereign means, and it's it's a lifetime portable identity for for any person, organization, or thing that not depend on any centralized. We are working right now in the centralized world. Everyone is talking about, and every identity is being governed by some centralized organization right now. So obviously, the decentralized will, make your life little distributed, and obviously the things are not never being taken away. The record and the data which is being stored underline is being distributed across the ledger. Next slide, please. So I will touch upon the three models of digital identity over here. So the first is a centralized, which Jim also mentioned about in this slide, where our data is right now, and how we basically try to, disembark from the centralized to a decentralized model. Right now, you are the part of the organization, and someone is maintaining your identity, and so your data on their side. There are different, the second one is a third-party IDP, a federated identity, where your federation will work being top of the identity provider, who is basically pass your ascension or your attributes to the organization. So this is the second one, which everyone knows, and I think most of the third one is the self-sovereign, which I think Jim also touched upon on the a peer connection between, and so obviously it's being stored under the distributed ledger. The connection is trust. The whole model is a cryptographic model. There is you are the one who basically owns the credentials. You are the one who is having a private access to your wallet, and nobody can touch upon unless you're sharing a private key to anybody. So it's a self-sovereign way of basically implementing the solution. So this is kind of dates which I was talking about previously. The user is taking a digital wallet on his hand, and your credentials are being verified by the verifier and the DDoT. So I'll talk about DDoT in a couple of slides, next couple of slides. But these are the few standards that has been being implemented and has been right now under the hook, which covers actual the authenticate over the connection. So this is some of the emerging open standards which are coming up. DDoT, Dkms, DED. So these are the few being right now driven by W3C and DIF, and many organizations are working on this. Next slide, please. So you will not get only one date, but you will have thousands, because you are basically talking to many different providers. So the date, it's kind of an interoperable credentials over a different wallets. So what exactly DID is, it's basically an identifier, and obviously it's kind of your no longer being considered with your social security number, or you've been tagged as a username or Twitter handle, but they are not a human friendly and it's hard to remember. But that a great thing about them is you can prove that you own that and control that. So that's because the address of the public key or on a ledger is being, and you have a private key. So that's identified that being distributed over under the blockchain. Next slide, please. So each one will give you a lifetime encrypted private channel with another person, organization, or thing. So that's the beauty of this blockchain and the distributed identity over here. It's kind of driven through, the platform which Sovereign and other key vendors are working right now and focusing, over how you can register, how they can help you in integrating with your dates directly on the public or the private blockchain or on the distributed network. Next slide, please. So you will you will use it's not being to prove your identity, but to exchange your credentials. That's where, it's a permanent identifier. It never needs to be changed. It's a kind of resolvable and also a cryptographically verifiable identifier. So that's where the credentials being shared across digitally over the network, and there is no centralized registration authorities required. Next slide, please. Best of all, there is no central, which I mentioned. Every date is registered directly on the blockchain and a distributed network. So that's where the fundamental and principle of the blockchain technology means. It's available over several blockchains. Some of them are pre-existing, others are created specifically for the purpose of a self-sovereign like Sovereign. Next slide, please. So this is a syntax. It's kind of a namespace. Basically from the background of computer science, or you can see how the IP address scheme works like. So it's similar to the different classes. The first part is a scheme. The second is identifier namespace, being how you basically identify by your UUID, and the namespace specific is the random number which you see looks like to be. So the method specification is that there is a specific identifier which is stored on the blockchain, is being driven on the sovereign network, and the method specific can tell how to interpret the method specific identifier that comes after it. I'll show the next slide, please. So this is a method specific identifier, which is basically how to read, how to write a date on the specific blockchain. Each network can have its own specification. There is a big list of dates available already in the market. Each of the specs describes what method specific identifier, how it can be constructed. So anybody can go to the GitHub, did method spec and identify it in the same as a username on the websites. The spec also describes how you can create, read, update, and delete some of the dates and the documentation. Next slide, please. So these are the few date, which already been existing. Sovereign are the most popular one, Bitcoin reference, Ethereum, Uport, whereas IPVS and Blockstack. So everyone is being identified with their own prefix and the scheme name, which most of the vendors and the commercial organizations are being using and piloting the product, their projects as well. Next slide, please. This is a standard elements of date talk. So as I mentioned, it's a self-description that is identified a set of public keys for the verification. You need some public key, right, at the cryptographic. There is a set of authentication protocols for authentication and set of service endpoints. So these elements basically talk about your overall scheme and overall way how basically you can describe and specifically authenticate by your username or by your which you used to do earlier. We'll ask you for the password, how you can verify with the data in your own database. With dates, you can only tell the website, this is my date. That website can look for your public key and ask you to sign a challenge with your private key. That's it. The website then verify the signature with the public key. That's the beauty of that. Next slide, please. So at Dkms, it's a very popular term. I think if you have been working on this space, and we are talking a lot on the Dkms model. So this is a key management, and most of the decentralized key management systems have been make sure that your keys or wallet are not locked in a specific vendor. You can have a different wallets on a different devices that can all interoperate. So definitely it's kind of a need right now, and this standard is being very robust and highly usable key recovery mechanism. Next slide, please. So it supports both offline recovery as a paper wallet, which, and the social recovery like a trustee methods. So as I mentioned, it's kind of, driven on both, not logged with specific vendor, but at the same time, you can use to recover in online and offline mode. Next slide, please. So as Jim mentioned about the verifiable credentials, I'll touch base a little bit on that part as well, and go a little deeper. So what means and what verifiable credentials mean? That it's a format for interoperable cryptographical credentials being defined by W3C. And there is a working group who's been working very closely, and basically your credential being shared across different different part of your work which you are doing with any industry specific. So it's the beauty of how you basically verify your credentials being trusted by issuer and verifier. Next slide, please. So this is a stack which right now been actively working, and some organizations already been implementing the stack, the data layer, the cloud layer, the verifiable credentials, and identifier owners. So each of the stack on the left and right being, this is a user who is owning the wallet on the phone on the and the right side is your verifier who's being making connection and basically exchanging the credentials. So that's the stack been driven and being formed, and a lot of different work has been done on this specific side. Next slide, please. This is ecosystem which Jim also mentioned, how the issuer is signing a credential, and basically a holder is holding the wallet, and the phone countersigns the credential and it presents to the verifier. So there is, I can assure you that on the network, on the underlying network, there is nothing, any PII or any personal identification or PHI information related to an individual is not being stored. It's only the specific identifier which governs talk about the public keys are being stored under the underlying system over here. So it's very much similar to what Jim has discussed. Next slide, please. So this is again a pairwise unique that's we countersigns the credential, and basically the pair is being created over there, in terms of how each of the specific connection with your peer or the device or your application, or could be any company being created in the public and private key pairs, which you will store on the keys in the digital wallet, which I mentioned before. So this is something, kind of keys that obviously nobody wants to lose. It's a key of your kingdom as a private key. I mean, issued by yourself, can be issued by your peer as well, or could be any passport office, or could be any driver license office, or your employer, or your coffee company, whosoever you can talk about. So you can create a credential which can be verified by the public key, and the key pair, the public key, is being stored on the ledger, which I mentioned before. So that's the beauty of this a sovereign verifiable credential, which anybody can use at this time. Next slide, please. So this is again a more kind of a zero knowledge credential. I think Jim did mention about zero knowledge proof, and a little bit I want to touch upon that topic, since data is with many checks and balances in place today. to curb the hacking attempts, it's not always perfect. So a system can be compromised in many ways. They often involve lack security, poor cybersecurity practice. Our data is a gold, right now for the hackers, and they want to steal your information. So what can you do about this, right? So individuals are often not in control over their own identities. That's where the personal information is regularly shared without the person knowing about it. That's what the principles of GDPR Jim has talked about. So any banks, merchants, creditors, agencies regularly share your information, for review purposes. So that's where the zero knowledge proof has been actively come and basically it's cryptographically stored on the blockchain using the hash function. That's when the hash value is being available for those who want to verify your identity. That's the zero knowledge proof, which anybody specifically your personal information can be obscured by your hybrid system, which is blockchain, and database to verify your individual's identification. So it can be, this can be implemented as a system called self-sovereign identity with a zero knowledge proof. That is the beauty of that. Next slide, please. So that's pretty much it from my side.
Kapil, that's great. I think that you shared a lot of information, and for the folks that are super technical and all of the, one of the things that came up in Q&A from Yvonne, and you may have answered it, but maybe I'll give Jim a shot, or both, either one of you want to kind of comment on this, is, what Yvonne asked, what can be classified as a verifiable credential, and who verifies that they are indeed authentic? Do you want to comment on that for Yvonne?
Yeah, I'll start off and I'll turn it over to Kapil because I know he's got an excellent perspective on it as well. First of all, in the world today, your verifiable credentials are your physical credentials. So we're talking passports, driver's license, the same documents and the same physical credentials you're used to attesting to that you carry around in a physical wallet. When you move into the world of verifiable credentials, that is a digital standard, an internationally accepted digital standard, to produce something in a mobile wallet that is just like and can be used just like your physical credentials are used today. And Kapil, I know you've got great thoughts on this as well.
Yeah, thanks, Jim. I think you really touched upon that. Let's take an example of a driving license institute, right? A DMV, and the verifiable claim. What exactly is the driving license looks like to be from that DMV, right? So let's call a driving license institute or a DMV the issuer. They are going to issue your driver license, right? So that's where the verifiable credentials hold and specifically been called as a verifiable or digital identity over here. That's it's all about how you every single identity and every single claim which user is making a connection between parties. And the physical form, as you mentioned, it's being converted into a digital form. That's my perspective. Yeah,
absolutely. And Yvonne brings up another good point I want to touch on too, which is, how does somebody verify it? It's really almost kind of deceptively simple. I think Kapil would agree with me that the standard, the technology behind what a verifiable credential is, what that object is that goes in your wallet, how a developer creates it, how you use it, how it works within this decentralized architecture. It's not overly sophisticated or difficult coding and programming and software. What's really, really difficult is to get three people to sit down at a table and agree upon the fact that they're going to trust one another's credentials. We are where we are in global travel and the use of the Iata travel pass, for instance, because the EU has one travel certificate standard. The WHO has another travel certificate standard. The US hasn't standardized on anything, but there are certain standards that are kind of coming which aren't standardized amongst the standards. And just that socio-cultural trust that if I present a credential from a trusted issuer, you as the verifier is going to accept it, is really the challenging part, not the architecture.
Totally agreed.
Yeah.
I think.
Thanks, Jim. Yeah, we have a couple other questions here. So one is and Yvonne kind of follows up on that is she's looking specifically at qualifications. Who would attest that the certificates are real? And I think that's, Jim, you kind of commented that on the end, is that really the the validity of the certificate is agreed to by the parties that are participating. So just like when you present your Visa card from Bank of America at a retailer, the trust relationship is that card and that little machine you stuff it into, or that you wave your card over, and the proprietor of the store have agreed that there's a way for them to exchange goods for services by waving that magic card in front of that device, right? And so that trust relationship has been built, and the credential here is the same sort of thing, is that there's trust that the thing that you present at a store or wherever you're going, the relationship between what you present and the person that's accepting that credential, that trust has been happening just like that transaction with your credit card. It's a similar frame, it's just electronic as opposed to you having a physical card, and the bank and the retailer, the bridging that gap of trust between an enterprise that's issuing a certificate and a consumer of that certificate, and what connects those two things to initiate that trust, similar to your credit card. If you think of that in the same paradigm, I think you'll kind of get the concept of how that would work in reality. So,
well said, Mike.
We got a couple other questions here. So one is from PK. I think everybody's concerned about security, ransomware attacks. I know in healthcare there have been a few organizations that have been hit by that pretty heavily, or they've had some difficult times. So if centralized systems are prone to ransomware attacks, can either of you or both of you comment on how much reduction in risk should a business anticipate for blockchain-based decentralized systems? And that's from PK.
Yeah, so it's still a little tough to quantifiably understand how much risk might be reduced in any particular architecture or scenario. But one of the big things that a decentralized identity enables is something else we call zero trust architecture, which there's hours of reading and discussion around, but built on this concept that any two entities or organizations that are verifying their identity for authentication together have to establish a mode of trust. And as Kapil and I have discussed, that mode of trust is the verifiable credential. Ransomware takes advantages of vulnerabilities in centralized systems where authentication is easily compromisable, perhaps because the keys are publicly available, or it's a simple username or password structure. In zero trust architecture and decentralized identity, you may have two parties that inherently don't trust each other, but they've agreed upon a credential format to say that their relationship is authentic. And that is a significant contributor. Zero trust architecture in general is a significant contributor to the idea of reducing the sort of risk you have from ransomware. And Kapil, whatever your thoughts are too, sir.
Oh, definitely. I think with the zero knowledge trust, and that's the principle, that's the industry principle right now. And we have moved from, a traditional architecture from to a system where we have to have nobody want to give a privilege access to anybody, right? So we have a prover who is an individual, right? And a verifier who needs to verify. So in all case, all the prover needs to show a verifier is a value of X, right? Without showing the actual information. All this requires a proof of knowledge to verify that the individual is who is claimed to be. And that's a form of digital fingerprint that can prove by individual identity, right? So that's the validity of the proof lies under the cryptographic hash function. That's a beauty of the zero knowledge trust proof. And without a doubt, the identity is valid.
Yeah. And I think that's, again, the decentralization means even if one node may be compromised, the remaining nodes are still independent. So we have another question here from Sandeep. How robust when integration of SSI with public blockchain? So I'm trying to audit that question as I say it. So I'm guessing he's trying to ask about the SSI and public blockchain, if there's a robust integration there.
That's a great question. And speaking from the Linux Foundation standpoint, I know the activities Kapil and I have been involved in, we have a number of architectural efforts to be able to integrate what we've laid out in terms of how SSI works and how a blockchain supports SSI with a public blockchain such as a Quorum or an Ethereum or a Bitcoin. And from a concept standpoint, as we get more into things like central bank digital currencies, CBDCs, and other aspects of cryptocurrency exchange, looking at how the SSI, the verifiable credential, can be tied as an identifier using that zero knowledge proof to a financial transaction associated with a public blockchain cryptocurrency type ledger. There's quite a few efforts. I know Kapil is involved in it as well, where we talk about blockchain interoperability and process interoperability to be able to do that. So if you're using blockchain A for identity, it'll talk to blockchain B that's doing financial transactions. But all of that work is certainly ongoing.
Totally agreed. I think that's where we are. Every single organizations want to go on using the a public network, a public blockchain, and talking interoperability between the different blockchains. It's secured. Your information is not being an API information, as I mentioned before, not being stored on the public blockchain. It's the identifier which is stored on that. So that's where the modern psychology comes in, and all your embarrassing transactions which is happening underlying is being secured by the network itself. And you're talking about how basically it managed and being governed by different organizations, and that's where with the learning and the knowledge work is coming up, and various standards has been built up on top of it. And many organizations have already been tied up and running a lot of their pilots on the public blockchain.
Yeah, I think those are all good points. And I think we got a couple more questions here. So Jill has a good question, which I think is a longer answer, but Terrell has a shorter one. And I'll let you both comment on just kind of the types of data to put on blockchain. So Terrell's question is, can X-rays be put in wallets or put on blockchain? And I think just from a conceptual standpoint, I think you touched on that, Kapil, just a second ago, is just, what sorts of information gets put on chain versus off chain? And can you both of you comment about, at one point, 3 or 4 years ago, I was at a HIMSS presentation where blockchain was going to replace Epic and EMRs and was going to toast your bread and drive your car to work and all that sort of stuff. So can you just talk about the kind of candidates, especially in healthcare, the types of data that may be on or off chain and what that looks like? And just to directly respond to Terrell around the X-ray question.
Sure, I'll take 30 seconds, and it's a great question, Terrell, as you understand applications of blockchains in different industries. And regardless of what the use case might be, blockchains are really there for the transactions. As Kapil and I have talked about, you use it as part of the transaction register for decentralized identifiers and keeping track of where the decentralized identifiers are. In other use cases for financial services and cryptocurrency, it forms that accounting layer for being able to track who has what cryptocurrency and what transactions are going on. But it really stinks in terms of just using it like a general old database. So for the X-ray example, for instance, perhaps you have X-rays in a database at one hospital location. You want to go someplace else. What we would argue is that in having your own patient-centric identity and managing your own healthcare data, you'd have a decentralized identifier that was unique to you, assigned to that X-ray at whatever database that X-ray resided. And then when you wanted to go someplace else, you could use that and use the blockchain transaction to say that information from that database was moved to another database that you authorized and gave you a consent record of how that data was shared. But blockchains in and of themselves are not really built to store a bunch of information. And if you put something like an X-ray onto a blockchain, that's technically personal health or protected health information, and you're putting it onto the blockchain, which is also something else you don't want to do. And Kapil, your thoughts as well, sir.
Definitely. I think you covered most of the part over here. So from the perspective of, there are different hyperledgers or different blockchain technologies being driven. Like if anybody has any idea on the different standards, like a Hyperledger Indy or Hyperledger Aries. So every single being tools or this Hyperledger solutions are being developed for distributed, a permission solution. It's a global scale, right? And obviously it's similar to what just Jim mentioned about how the specific database or the X-rays being, it's the beauty over here is that, it accumulates all your credentials and authenticate themselves without the intermediaries. And it's make it possible for system to, cover and access without making any calls or any specific, and it enables the issuance. It enables the management, and obviously everything is private. There is nothing, no data. And if anybody is talking about that specific data is being stored on the underlying network, in that case, that is not a blockchain. That's the beauty of that. It's decentralized.
Yeah, and I think that just to kind of, as we're talking about medical information, and Jill has a question about the impact on HIPAA, and I think one of the things, again, based on what we've been talking about and what's on chain and off chain, and really how that works, is Jill's question as a medical practitioner. What's the impact on HIPAA? It seems like this technology may supersede the need for a policy. And then she gives a shout out to the patientary crew. So Jill, thank you for that. So can you talk about, again, I think what, from a security, an exchange standpoint, I think from a HIPAA standpoint, as blockchain is an awesome consent tool, maybe you can kind of speak to, medical data exchange or an interoperability related to HIPAA, or policy standpoint, policies like HIPAA, and how blockchain might impact that. So.
Absolutely, and I get really excited about this topic when you start talking decentralized identity in healthcare, mainly because HIPAA in many ways has been a crutch so far. I'm sure that everyone who has listened here has had experiences around HIPAA where they're told they can't have access to their own information because HIPAA won't allow it, which of course is ridiculous. The concepts of the General Data Protection Regulation, GDPR, as we've described already, get into the fact that it considers your data to be yours and that you have ultimate control over it. You can decide how it's shared, you can decide on parameters around consent, and most importantly, at the end of the day, you can say, hey, give it all back to me, and you can't hold on to any of it. That actually kind of contradicts what HIPAA is all about, which was written at a time that data was just stored in centralized databases and owned by individuals. There's obviously lots of talk about patients owning their own data, and in 49 out of 50 states in the US, whoever owns the EHR system owns the data in it, regardless of the HIPAA regulations. So decentralized identity being applied to your own medical information and fulfilling the 21st Century Cures Act is a big jump for the way that a lot of business processes handle now, especially when organizations just want to fax something someplace. So there's as much socio-cultural change as there is technical change here. So that's a good question, Joe.
Great. I think that's where the current models for the PHI storage on EHR platforms are being used, and encryption and the data backup is a key aspect. The best practices the healthcare professionals can use, to mitigate the risk associated with the EHRs. These protections act as a band-aid, right? So obviously, to protect the PHI in the unprecedented new ways, that's where the decentralized nature comes in. And the blockchain certainly has a potential to create the better quality of care of patients in the healthcare settings. There is a transparency, as he mentioned, and the interoperability, right? That has been major barriers for EHR adoption, but at new changes or new standards that is coming up in this technology, it is a breakthrough and that the industry needs.
Great. Well, we have at least one more question in the chat, and we're getting close to time here. So, Emre, and I apologize, I'm butchering your name here, but is there any market information available on actual working SSI models in use? Who are the leading market players today in terms of the number of users or implementations? And again, I think part of, when you talk about blockchain, people don't run around when you look at, and again, not working in healthcare, Epic is a big name, Cerner is a big name, Athena, you talk about the vendors. And really, when you talk about blockchain, I think everybody knows the big players, but who's actually implemented it? What does it look like based on the number of users or participants in a consortium? So can you either of you comment on that?
Yeah, I'd capture that IBM has some fairly large scale implementations with their HealthPass work, both in the US and overseas. Iata is another one that's involving a couple different companies. for international travel. I forget the exact number, I'm going to butcher it, but I think they're up to something like 17 airlines or so globally. They're starting to use it. And then beyond that, there's a number of smaller companies, and I think it's been fostering a smaller company ecosystem, because the work being done here that Kapil and I are involved in is all open standards and open source. So, God bless Epic, but they built a system and were able to develop it and market it into a market area as one company with their own technology. Though Epic itself has some elements of open source that are built into it in the way like the MUMPS database concept. Because so much of this work around self-sovereign identity has been fostered in open source communities and collaborative environments, you don't necessarily have like one big market leader per se, but a number of companies that are all still pioneers. And welcome your thoughts too on that, Kapil.
Definitely. I think this is something, it's being at an open standards. Various vendors, various partners are coming up. Like IBM it's a strong network in the overall space, as Jim mentioned, and like Evrenem, who is working on European as well as Canadian market. So they have some pilot running on their underlying network. Small vendors like One Cosmos is one of the other leading capturing the market, and specifically on the passwordless and the blockchain decentralized world. So there are a few, but to name to start with, I think these are the ones. If somebody wants to get in and want to try it out, they are giving out of the box connectivity and the DEDs to test it out and run some pilots on their own platform.
Yeah, and I think that, again, Jim mentioned it earlier, I think the big challenge is really the consortium, is getting organizations to align from a policy and administration standpoint that they want to leverage the technologies, and look at how you build that consortium or that network. And there are definitely a number of networks from my perspective of health information exchange, Care Quality Commonwealth. Some of the vendors have built their own exchange networks, and so there's a natural consortium there. And I think, again, as opposed to from my perspective, pushing all the data, we have a redundant data process, right? Every piece of data gets replicated everywhere, as opposed to looking at a source of truth. And I have a presentation I've done a couple times about how, if you combine identity and essentially the longitudinal care record into a blockchain framework, where you're really just tracking those encounters and requiring the organizations that are part of your care, basically part of your care team, anytime you engage with them, that they provide essentially a credential or a tracking device, for lack of a better term, to that interaction, so that you can get that information from them. When you look at those two things, then you can consent on sharing that with someone else that's part of the network, and really kind of manage your consent to exchange, as well as having that view across that longitudinal care record with multiple organizations, as long as they're all participating. So we're getting to the end of time. We got about 2 minutes left, so we'll give you each a minute. In summary, again, appreciate your expertise and sharing all of the information. I think everybody's really learned a lot today. Do you have any summary or final thoughts? And since Jim, you went first, I'll let Kapil go first, and then Jim, and then we'll thank the audience and Patientory for having us here today.
Absolutely. So I think my concluded thought over here is that the future is really bright, and the things are changing drastically. The breaches are happening. The overall market is growing. If anybody wants to participate and come on to join, this network is open, and I want everyone to participate. Come and join the SSI Meetup. Be thoughtful with their ideas. Be thoughtful what they want to do, and have a meaningful way of implementing the solution. So that's my concluded thought.
Thanks.
Yeah, and I'll plug Kapil's SSI Meetup as well. It's an excellent forum. I'll also add to it that the Decentralized Identity Foundation, Trust Over IP Foundation, Hyperledger are always looking for new members, and there are great ways to get involved there. Matter of fact, I forego the Hyperledger Identity Working Group meeting today so I could join for this webinar. And then beyond that, thank you, Michael. Thank you, Kapil. And I hope everyone has a wonderful holiday season.
Yes, I thank everyone, the Patientory team for putting this together, allowing all of us to come together and share more information, learn a little bit, and really get inspired by the hats for the holidays. Everybody be safe, get that booster shot, wear your masks, and have a good holiday. Thanks, everybody, and take care.